the okay na. Got it. You pushed. That is, you wrote for the KC only, not KP. But they are asking relationship between KP and KC. This is the 3-mark question they can ask. 3-mark question. 3-mark question. This is the KC. If you are writing KP, how you can write partial pressure of P power C, that is P D power D. In term of, here is the PA power going to be A, and here is PB power going to be B. From ideal gas equation, you know. So what is there from the ideal gas equation? You know na, what is ideal gas equation? PV is equal to nRT.
Can you give me one time, sir? I want to derive that one, sir. I can do it. I know how to do that.
Okay, do it,
Yes.
please.
Sir, I was doing also, suddenly got disconnected actually.
Yes, I can understand. Do it. And you know na, what is ideal?
Yes, sir. PV equal to no.
Okay. Okay. Done.
No, sir.
Okay.
No, sir. This is
Okay. Okay. Super. Very good. You realize this. Hmm.
7, sir. Gone.
You can skip the step also little bit.
Last step only.
Okay. Nowadays, you are not attending the online class chemistry.
No, sir. Sir, not attending from a very long time.
No, chemistry, I'm asking. Chemistry, 3-4 days you will make that no time.
So 3-4 page, what I will make?
3-4 days you do not attend the chemistry class.
So last class was 3 days ago.
Oh, that is what. Okay, no problem. Okay. Thank you. That is very good. Okay. This is correct one. You will get full marks for it. Okay, not a problem. Now, what we have to do, Sanoy, can I give one more question? Little bit.
Yes.
This is also important one. Derive relationship between derive
Casey and
relation.
Chris.
Okay, I am not a relationship between it is homework. No, relationship between homework it is. CP minus CV is equal to R. This is the one. Second one. This is the one and second. Here the next one. Second one is there. Work done in isothermal. This is the isothermal reversible expansion of gas. Reversible expansion of gas. Do you know this one?
No, sir. This second one I do not know. The second one is from this chapter or from that thermodynamics?
Thermodynamics. This is also from thermodynamics only. Here is W is equal to minus 2.303 RT log V2 upon V1. This is the expression, or that is W is equal to minus 2.303 RT log. Okay. It is the P1 by P2. Either you can derive. Okay. One question I am giving you. Wait. Did you write the question now? This one.
Yes.
Oh, okay. You send me when you get free time. Question. One is at what temperature? At what temperature? At what temperature? The reaction will be at what temperature? The reaction will be spontaneous. At what temperature the reaction will be spontaneous for A giving B plus C, where del H is equal to, they have given 200 kilojoule per mole, and del S is equal to 0.2. This is the kilojoule mole inverse Kelvin inverse. Okay, solve this one. Can you do this one?
Hmm. So second one I cannot do. The first one I can try to maybe.
This one you need to do. This is only one now. This is only one question
Hmm.
only. Hmm. Should I do
This.
or you are going? One question we have done from the NCRT. This is from the NCRT type question. From
So let me see how to do.
Gibbs Helmholtz equation. What is Gibbs Helmholtz equation, Sanu? Delta G is equal to del H minus T del S at equilibrium. At equilibrium. If you are going at equilibrium. So what it is going to be? Delta G is equal to going to be 0. So 0 is equal to del H minus T del S. So here is del H is equal to T del S. So T is equal to del H by del S. Del H value they have given 200. Okay. And here they have given 0.2. If you are multiplying by 10, so it will be 2000 divided by 2. It will be 1000. So 1000. At 1000 it is equilibrium. It is equilibrium. And equilibrium is spontaneous. Spontaneity increases on increasing the temperature. So above, if you are writing above 1000 Kelvin, the reaction will be spontaneous. The reaction will be spontaneous. Can't you understand this one? Yes, yeah, no.
Yes.
Can I reach?
Yes.
What will be? Little bit I'm checking you how much you study. What will be sine of delta H and del S for A? PCl5, it is converting into PCl3 plus Cl2. B, N2 plus 3H2 giving 2NH3. Okay, do it. The neat paper came. Are you going to apply or not?
Sir, apply means I do not understand, sir, what you are
Neat,
talking about.
that one entrance exam na, the
Huh?
that is notification came out na.
Notification, sir, which one?
Neat UG.
So, sir, that I will be appearing next year, no?
Till now you are in. No, yes, yes. This is your first year. Okay, tell me the what is sign of delta H and delta S.
So for first one would be exothermic process. So sir, the delta H should be negative and delta S will be positive.
Okay, negative. Delta S.
Delta H equal to delta S minus T del S.
When number of molecule increases, so randomness also increases. And randomness
Yes,
increases
positive.
means that is going to be negative. Here also, these all are the negative, negative.
So randomness increases means sir entropy will increase, no?
Last one is problematic. A number of molecule decrease. Now here, how many are there? 4. Here is 2.
So not talking about this one. I'm talking about the upper one, delta S.
Such a number of
If the
molecule increase. Na delta S will be positive. You are saying.
yes, sir.
And here is the, if you are talking about this one, PCl5, it got broken into the 2 part. Okay.
Hmm.
So energy required. Energy going to be
Energy
absorbed.
per delta H will also be positive.
That is also positive. Similar will be the this one. This will be number of molecule decrease na. So entropy will be decreased. 4 moles or 2 mole. And here is if you talk about the delta H value, here is the heat also released, student. Heat also it is given. Okay, 98 kilojoule per mole. So what is going to happen here for this reaction? Heat is already releasing. So it will be the negative or negative. Heat automatically releasing, that is exothermic reaction. This is exothermic, this is indo. Okay, this type of question they may ask, kindly keep in mind. Okay, next one. What we are going to do? Arrhenius, we have done Bronsted acid base concept. Bronsted acid base concept. Acid base concept. Have you any idea about the Bronsted acid base concept, Sana? Any idea?
No, 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 sir. I do not have any idea.
No idea.
No.
See, this is the simple to the Arrhenius acid base concept. Bronsted acid base concept. That is the similar to Arrhenius acid base concept. Acid is the same. First point there is no solvent required. So first point is no solvent required. Here they are not talking about the solvent. First point is this one. Second, if you are talking about acid, gives H plus, gives H plus. This one.
There only what the thing is that if they are categorized as acid, then they are capable to give H plus and base then able to take H plus.
So this is base is what
Sir,
takes H
RNA
plus.
has told that if it is acid, it will give H plus. If it is base, it will give OH minus.
Yes, correct. So this is point. Now, if I will tell you one more example. So if you see this one in the case of the HCl, so what it is going to give H plus plus Cl in the vapor phase itself. So it is giving H plus ion. So it is the Bronsted acid. Many things are the same. Bronsted acid, Arrhenius acid are the same. There is no difference in that. Now base. Base if talk about the NH3. NH3. So it is it can be accepting the low, no, H plus ion. It is having the lone pair electron. Now it can accept this one. So what is there? It is going to form NH4 plus. So this is what since it accepted the what? H plus ion. So it is the what base? This is Bronsted base. Bronsted base. Are you able to understand this?
Hmm.
Many examples we can give. Here, suppose that is OH minus ion is there. It can accept the H plus. So what it is going to accepting means it is forming H2O. So this is again going to be Bronsted base. See, whatever the species which can accept the H plus ion, that is going to be Bronsted base, and that can give H plus ion, that is going to be the Bronsted acid. This is what the simple concept is there. Okay. First one. Let us move on the next slide. Reaction between they are saying reaction between Bronsted, this is their Bronsted base and Bronsted acid. Okay, if you are treating the Bronsted and Bronsted base acid, what it is going to Bronsted acid. So what it is going to give? It gives conjugate acid base pair. Conjugate acid base pair. What in case of Arrhenius you are getting between reaction between acid and base? What you are getting?
Salt and water.
Salt and water. But here you are not going to get salt and water. Even in the Lewis concept, you are not going to get the salt and water. In the Lewis concept, you are going to get the coordination compound. Now, suppose you are taking the H2O and another things you are taking the NH3. It is the Lewis base. I am supposed to. Otherwise, you can, here is the what we are taking. Here is the Lewis, not Lewis base. Yeah. What will be there? Bronsted base. And this we are considering Bronsted acid. Now, reversibly, what is going to happen? NH4 plus it will give NH4. And here is OH minus. So Bronsted acid is having the Bronsted base. It convert into Bronsted acid is having conjugate base. Conjugate base. And base is having what is there? Base is having conjugate acid. Conjugate acid. Conjugate acid. Now if you talk about the conjugate acid, how it is formed? Conjugate acid base plus H plus ion. If you are adding, so you will get the conjugate acid. If I will talk about conjugate base. So conjugate base means acid minus H plus ion. This is what the concept is. Can't you understand?
Hmm.
I'm erasing this one. Can I
Hmm.
write the conjugate base and acid pair? Acid, conjugate base and conjugate acid pair for following species. For following species. Following species. What are there? Here I am writing the species. Here is the conjugate base. CB means conjugate base. CA means conjugate acid. Okay, start. Here is the H2, NH3, HCO3 minus, HSO4 minus, C2H5OH, HNO3. Okay. Wait. Here you see. if you are writing the conjugate base, so acid minus H plus it will be there. Acid minus H plus. So you are writing correctly or what? Okay. Write down. So this what you are writing, that is absolutely wrong. Okay, correct. What will be conjugate acid? Okay, good. That is correct. What you are writing 2 here. Should I tell the others one?
Sir, yes, you to tell the last two.
But the conjugate base you are not writing. Only you are writing the acid. Is it audible to you?
Yes, sir, audible.
Okay, thank you. See, in conjugate acid, what we write, that is base plus H plus. You add the whatever the species are there, you are adding the H plus. And here is whatever the species given. I am writing simply species minus H plus. Whatever species they have given minus H plus. And here is species. Whatever the species it is given, what you need to write. Okay, let me write here, rewrite. Conjugate acid. So whatever species is there, species. In the species you add the H plus. Conjugate acid base pair, what is there? Note. CB, conjugate base and conjugate acid only differ in what? Can you tell me? Only differ in H plus ion. Only differ in. So here H2O, that is correct. So what will be there? If you are adding the H2O plus H plus, what the species you are going to get? Tell me.
H2O2.
Ah,
No.
H2O2.
H3O plus.
H3O plus. So conjugate acid will be H3O plus. You added H plus. H2SO4. H2SO. What is there? No. C2H5. It is OH. A lone pair electron is there. You are adding the H plus. So what will happen? It is no C2H5 OH2 positive charge. This one. So this is. So here we are writing C2H5OH2. Here is positive charge. This is there in the 12th standard. This will come. Protonation of alcohol, protonated alcohol. HNO3. If you are talking about HNO3, here is lone pair electron is there. If you are adding H plus, it will accept the H plus. So H2NO3 positive charge. So here is it going to be H2NO3 positive charge. Conjugate base you are removing. So it will be what? One hydrogen you remove NH2 minus. Here is CO3 2 minus. Should I explain?
No.
Should I? Here is SO4 2 minus. Here is C2H5O minus. NO3 minus. Check whether you are able to or not.
Just one second. I will write this down.
Done.
No, no.
Can I erase?
Yes.
Okay. The next one is what we are having. Lewis acid base concept. This is Lewis acid base concept. Have you any idea about this one, Lewis acid base concept, Sanoy?
So which is electron deficient would be Lewis acid and which is electron rich will be the Lewis base.
Okay, wow, 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 very good. Lewis acid. They are lone pair acceptor. Lone pair acceptor. They are lone pair acceptor. Okay. This is what like case one. EG we are going case one. Okay. Electrophile. Whatever the electrophile are there. So electrophile are Lewis acid. Lewis acid. Okay. Like CH3 plus is there. NO2 plus is there. Okay. H plus is there. Okay. Okay. Cl plus, whatever the positive charge you may write. Okay. It will be the, what will be? This is the Lewis acid except H3O plus. Why H3O plus is not Lewis acid? Can you explain? Can you explain?
It's 3O plus.
It has completed octet. It has completed octet. If anything is having completed octet, it cannot accept the lone pair electron. So if it is not able to accept the lone pair electron, so it will not be Lewis acid. Case 2. Incomplete octet. Incomplete octet. BH3. This one. AlCl3. FeCl3. They all are having the incomplete octet. How many electrons are there in the valence shell? Aluminium. Aluminium configuration 283 and 3 electrons shared with the chlorine. Total electron is 6 electron. Here is also vacant. Here is also 6 electrons. So if incomplete octet, they will be acting as a Lewis acid. Okay. Case up now. If I will write the Lewis base, what is going to be Lewis base? They are lone pair donor. Lone pair donor. They are lone pair donor. Okay. Example 1. Negatively charged species. Negatively charged species. If you talk about negatively charged species, what are the negatively charged species? Suppose it is Cl minus. Okay. Br minus. I minus. Okay. Here H. Okay. Okay. Next one. Whatever the negative charge you can mention now, they are capable to donate lone pair electron. Okay. So this is the Lewis base. Next one. Example we are writing neutral molecules with lone pair electron, LP electron. Like what example you can get? This is the example type 2. Like H2O. H2O is having lone pair electron. So it is going to be Lewis base. NH3. This is what? Lewis base. Anything you can write. PH3. Lewis base. Neutral molecules having lone pair electron, they are also capable to donate lone pair electrons. So they are going to be Lewis base. Can you understand this? Can I erase?
Yes.
Okay. Reaction between. Next point is there. Reaction between Lewis acid and Lewis base. What compound is going to form the student? Reaction between Lewis acid and Lewis base.
Coordinate compound.
Coordinate compound. Why the coordinate? How the coordinate compound will form?
How it will form, sir? How I don't know.
But you need to explain, na? If anything is getting formed, that you need to explain. Okay. Lewis
Sir,
acid
for
base.
example, if H plus and Cl minus are combining, sir, then they will give HCl. So, sir, that way, the all the electron, that means that it is a coordinate compound. So, similarly, if they are being added, so they will give the coordinate compounds.
Suppose you are taking BH3 and another one is NH3. It donate lone pair electron to this one. It donating. So this is what is called coordinate compound. This is going to come coordinate compound. Coordinate compounds are also salt. Coordinate compound. This is also salt only. Okay, double salt, your complex salt. Suppose if I will go boron, boron is having number of valence electron. Do you know how many? How many valence electron is there in the boron? Huh?
One, five means two, three are there.
Three are there. Okay. So now if you see the octet of boron is not complete. Yes, yeah, no. Total
Yes.
electron is there 6. Now, what we are going to do here, NH3. NH3, if you are taking 1, 2, 3, 4, 5. Hydrogen we can mention here. This one. Hydrogen is having absolutely 1 electron. There is no doubt about it. Here you see nitrogen in case of ammonia, it is capable to what it is capable? It is capable to complete the octet. Okay. But other is not completed octet. So what will happen? Ammonia molecule share both the electron to the which one? BH3. So next one, since the both the electron is shared by the which one? NH3 molecule. So this is what the bond is forming is the coordinate bond. Can you understand?
Yes.
Coordinate bond. This is. Can I reach? Can I reach?
One second. So you can erase now.
Okay. How can you say? How can you say AlCl3 is Lewis acid? How can you say? This is question for you.
Uh, 13, 36. So ALC. One second. LCL3 means, so here L will be there, his valence is 3.
Hmm. That is outside of the Cl, it will be circle will be there. Inside Cl, where the Cl octet completing? How the dot structure
Oh,
you are?
sir, one second, sir. I'm drawing one second.
No
Here.
problem, no problem. I can understand that. You just no need to give this much, just little bit information. If you are giving, that is more than enough. Okay, okay. Means total electron is how many you are saying? 6 electron. Okay, good, good, good. Thank you. But your diagram is not correct till now. Okay, this one. Next one, you heading last class. I told you I will teach you gives free energy. But meanwhile, time gone. Gives free energy. We did not do this one. Yes. Problem also we didn't do this one. Gives free energy. So what how definition is there? It is maximum amount of energy. Maximum amount of energy. Amount of energy. Energy which is utilized in it is utilized in doing useful work. It is maximum amount of energy which is used in utilize you doing useful work. Can you understand this one? Are you getting this one? Definition. It is maximum amount of energy which is utilized in doing useful work. So if case 1, if del G value is negative, so process will be spontaneous. Process will be spontaneous. Del G is 0, the reaction will be equilibrium. Are you audible to it? It is audible to you. And delta G is equal to positive. This is going to be non-spontaneous. Non-spontaneous. If I will ask you, what do you mean by spontaneous and non-spontaneous? Can you tell me what is spontaneous? Sound is not coming, Sonal. Hello?
So that means the reaction will occur within very less time and so within itself only. So no extra energy is required.
Like what is there? Like that is if you spray the perfume in the room, it will reach by itself in the air, all the room. You need not to do any work. So this one, falling of water from the hill, you need not to do anything. It will do by itself only. Okay. So this is a spontaneous process. Non-spontaneous process means the doing work. Work is non-spontaneous process. So this is case is there. So I am writing the next one. Calculation of calculation of calculation of gives free energy. Gives free energy. Free energy. Gives free energy and types of process. Types of process. This gives free energy is having the only one condition is there. At what temperature it is going to be? The reaction is going to be spontaneous, that is being used. Getting? So
Yes.
there are many ways are there. Okay. Case 1. Case 1. What formula you can use? Del G is equal to del H minus T del S. Okay. 1. Case 2. Del G is equal to, or better you can write del G naught is equal to, it is the minus 2.303 RT log Kc. Case 4. Case 4. Del G naught,
Case 3.
case 3. Minus 2.303 RT log QC. So Kc and QCU, it is used for the knowing, used to know direction of equilibrium. Direction of equilibrium. Which one is coming more? That will be helpful now. Equilibrium. Case 4. Del G is equal to, del G is equal to minus 2.303 RT log E naught cell. This is also there. Case 5. Case 5. Del G naught is equal to summation of del G naught product minus summation of del G naught reactant. Del G not reactant. Is there any other things that we can do? No, that much is enough. That much will come. Max to max, this much is possible for the 5 cases. Out of this one, it is in the mostly it is their 12th standard. 12th. Okay. So let us go back and solve some of the problem. Here, Sanoy, a little change you do, please. Del G here is this one. You remove. This one is one thing is there. Del G not. Here you remove this one.
So only RT log is L.
This one is a little bit mistake. So it is there minus NFE not cell. Please. F is equal
And here
to
F means
Faraday constant. Faraday constant. Its value is 1 Faraday is equal to 96,500 Coulomb. 1 Faraday is equal to 96,500. Rest of the are correct. Only this one little bit mistake. Can I erase?
yes.
Okay, question 1. The standard, here they are talking about, the standard gives free energy in kilojoule per mole for a Daniel cell, DANNIEL. No, DANIEL. Do you know Daniel cell?
No.
You must be knowing. Daniel cell having E naught value, how much there is somewhere? 1.1 volt. Okay. Option they have given. Daniel cell in bracket, zinc and copper electrode.
Oh, acha, acha. Zinc and copper are seen many times.
Ha. So answer they have given 213, 212.3, 106.2, 424.6, 53.1. They all are, 3 are negative, 1 is positive. Can you do? Can you try? Or should I do?
No, also do.
Oh.
So here in the one formula you give minus NFE not cell. So what is the value of N for that one?
What, Sanwan?
The last slide,
Number
case
of
number 4, it
electron.
was
N means number of electron involved. Here, I think I erased that one.
number of electrons involved in moles. Now we will do 1 mole, 2 mole like that.
N means number of electron only. Number of electron. Like if you talk about Zn. So Zn plus Cu2 plus. So what is happening? Zn2 plus Cu. So this is oxidized here. So it is giving 2 electron and this electron is used to reduced here. So it seems that is 4 electron with N value is how much? 2. Yes or no?
Yes.
Now solve. A Coulomb volt, if you are talking Coulomb volt is equal to joule.
Now, sir, here, sir, we will use the formula minus NFE. So, sir, minus N I got to writing 2. Sir, what will be placing in place of F?
And E naught cell, E naught cell. So it is minus
In
2, 96,500 into E naught value they have given now 1 point. So it is going to be in joule. So you can solve this one, how much it is
answer
coming.
A, answer A, answer A. The first one is the answer, -2 and 2.
Okay. So the first one, it will come, that is the 212.3. No, 0.3 kilojoule per mole. This is okay. Next one. Here question they are saying, so that the reaction CO plus half O2, CO2 at 300 Kelvin is spontaneous. Spontaneous. If gives free energy, if gives free energy or H, if gives free energy or H. What are the gives free energy? Delta F G naught CO2. They have given minus 394.4. Delta F G naught CO. They have given 137. 137.2. And note, for universal molecule, delta G naught is 0. That is, if it is O2, O2 already found in the nature, no, so its value will be 0. Okay, N2, its value will be 0. They are the universal molecule, they are already present. How can you do solution? If I will talk about here, so
Sir,
del
let me
G,
do.
thank you, thank you. They are asking is only gives free energy, not a standard. If they are asking is standard, so you use the term is standard. Product minus reactant. Summation of product minus summation of reactant. Good, 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 good. Good, very good, very good. Hmm. 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 Here is minus 137 is there. I did mistake here. They have said minus 137. Enthalpy of formation 137, minus 137. I did mistake. So it will be minus. Here is the minus, 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 it will become plus. So here little bit mistakes are
Then
there.
also it will be okay only, nothing will be problem.
Yes, yes, yes. So here value they are saying minus 257 like that. That is going to be
40
negative.
minutes.
Negative only, no?
Yes.
Okay. So this type of problem, I think you will be able to solve also. So what when I'm checking your concept, whether it is clear or not, there are many problems. We will do that one. Calculate delta G naught for mg plus 2ag plus. It is going to be mg2 plus 2ag. E naught cell they have given 2.99. Solve it at 298. In kilojoule per mole.
Not
Okay, do it.
E naught cell 2.99 find G. Del
Hmm.
G0.
Hmm.
Number of electrons transfer. Sir, here N will be 2, no? N
Yes,
will be
yes,
2.
yes, yes.
Sort of in 2.99.
Hmm. 2.99, yes. Hmm. Hmm.
54. This will be
Uh,
54.
hmm.
57.
Hmm. 570. Okay, good, good. Joule. So
So
here
the
in
unit
the
for this is Joule only,
this
na?
is Joule only. Then you need to convert into kilojoule. Okay. Correct only. In the if you are not doing rounding up, na, so del G value they have given in the book 577.649. That is minus 578. Here it
Sir,
is
that is
coming 9.
because they are doing. Sir,
Sorry.
2.99, na? I took it 3. So that is why this
Yes, yes,
deviation
yes.
in values.
Okay, no problem, no problem, no problem. Next. They are saying the equilibrium constant of a reaction each 70, each I'm giving 73, then it will create problem for the log values. Na? Each 10. I am taking the another one. Each 10. Then find del G naught value. Value they have given 5.744 minus 5.744 minus 2.744 plus 2.744. Okay. Can you try? Can you try this one?
Let me do.
Mhm.
Sir, del G0, then what will be value?
That equation, na, that equation you need to use. Del G naught is equal to minus 2.303, and here will be the RT log AC. Of R value, if you are talking about this one, so R will be that is R is equal to 8.314. Because you have to take in the joule. It will be joule, Kelvin inverse, mole inverse. R value very carefully with the unit we have to note. If it is kilojoule, we have to divide by the 3.
Sir?
If R value is in the kilojoule, then we need to divide by 3. Okay, solve it. Should I do?
Yes.
T value is there. Temperature also they have given. So no, where is the temperature? It will be generally at 298 Kelvin, but here what the temperature? 300 Kelvin. Temperature is 300 Kelvin. Hmm. Temperature is
So
at 3.
log case means 1. Log 10 means 1.
Option C. I need to take.
T log of 10.
What you are writing, nothing is visible to me.
I did not write, sir, here anything. That is why I'm writing. I'm actually doing it in the copy. That is.
Directly you don't know. I will tell you where you are doing mistake. Directly do there. Hmm.
Twenty-three into 82. Done.
Okay, this is correct one. Correct. Very good. Okay. So Sanvena, other type of problem I will do it next class. Okay. You can attend
Next
tomorrow
class.
also. Because I need to take offline. Students came here. So when you can take tomorrow, maybe possible or not. I will inform you now because here the marriage party is there. 3 days I am busy, but which date I am busy, I don't know. That is the my wife's sister marriage party is there. Marriage is there.
Okay.
So today night time I'm not available. Then there will be the Sangeet and there is one last day's marriage. So the school is going on in your school or the
Yes,
any
sir. But sir, now because only there what the school in the school, sir, all the teachers are doing only revision. So, sir, I was not going for the last 2 3 days. Sir, I will go again tomorrow.
No. You go for the revision now. Revision is very important. That is why your marks is coming in chemistry very less coming now. It is very serious problem. It should not come less. It should come more. Chemistry is easier than physics, you know. But
Yes.
somewhere you are doing mistake. Kindly rectify. You also you go for the revision. Otherwise, you ask notes from the your friends.
Yes, sir.
Otherwise,
That I will. That.
uh, uh, chemical.
I will go
You,
from tomorrow only. First, from 17 exam is only there.
uh-huh.
Sir, no 3 4 days class will be there. I will go, sir.
Oh,
Right.
okay. In our school, the exam is on 15 only. So
Hmm.
if daytime is I will free na 3 to 4, 3 to 4,
Hmm.
3 to 4 no 4 to 5 also. I will inform you. Right.
Yes.
Huh. Tomorrow I may be free at 4 to 5. You can use this time 4 to 5.
Yes, sir.
You can use this time 4 to 5. For the equilibrium, you check that is the equilibrium constant. No, ionization constant you are asking. No, many topic left. Ionization constant of acid Ka, then Kb is there, then pH is there. Okay, then the buffer solution is there. Buffer solution. Then what is there? Ionic product is there. Ionic product is there. Ionic product.
Hmm.
KSP is there. Okay. QSP is there. Next one, what is there? We are having one more common ion effect. Common ion effect. So this all the topic we have to cover. Okay. So we'll see you tomorrow, 4 to 5. If I am free, I will take the class, right?
Okay.
Okay. Bye na. Bye. Take care. Hmm.